Okay, as somebody who teaches Algebra 2, Pre-Calc, and Calc, I do a lot of training on finding the inverse function. And I'm finding this undo-do method much better. Also, the idea of getting to the identity of x as much better ways to explain this than just the trick of swapping y and x and showing the reflection over the line y equals x. All right, so here we have P of n equals 3 log 2 plus n minus 7. We want to find Q of n, the inverse of P and n, and we want to show that the two combination functions will result in a value of n. So going from the outside in, what has been done to n that needs to be undone? First, we are going to add 2. Then we're going to take the log, and then we're going to multiply by 3, and then we are going to subtract 7 or add a negative 7 as we've been shown. Okay, so in reverse, then we would want to use the additive inverse and add 7, use the multiplicative inverse and multiply by 1/3, and use the inverse of log, which is the exponential function, and we would want to add the additive inverse of negative 2. And now we just have to take n and do those things to it. So Q of n would equal n plus 7. We'll multiply that by 1/3. We'll place all of that in the exponent of e and add negative 2 so much faster than solving that equation going the other direction. Okay, now to show the results. So I will try to take you through steps as quickly as possible. All right, so first we're going to take Q of n that we have just found, and we're going to substitute it into P of n. In the next step, we are going to use the rule of logarithms to put things that are added together into multiplied logarithms, and dividing by those that are subtracted, or plus a negative 2, that will go into the denominator. So we are left with, so we have 3, and we have log 2 log e to the 1/3 n plus 7 over log of 2 plus the negative 7. We took the minus and we made it plus negative 7. So log 2 over the natural log of 2, that is a 1 pair. So we will do that in the next step. 1 is the multiplicative identity, so anything times 1 is itself. Log and the exponential function are inverse functions. So the inside here simplifies to 1/3 n plus 7. We will now use the associative property of multiplication to group the 3 and 1/3 together. 3 and 1/3 are multiplicative inverses, so they multiply to 1. 1 is the multiplicative identity, so anything times 1 is itself. 7 and negative 7 are additive inverses, so they are a 0 pair and add to 0. And 0 is the additive identity, so anything plus 0 is itself. All right, now let's see the case for going the other way. We want to do Q of P of n. So once we plug P of n into Q of n, this is what we have. So e to the 1/3, in the exponent was a plus a negative 7 plus 7. Those are additive inverses, so those add to 0. 0 is the additive identity. 1/3 and times 3, those are multiplicative inverses, so they will multiply to 1. Anything times 1 is itself, because 1 is the multiplicative identity. E and the logarithmic function are inverse functions, so they yield just the 2 plus n. We'll rearrange by the commutative property of addition. 2 plus negative 2, those are additive inverses, so they add to the additive identity of 0. 0 plus n is just n because 0 is the additive identity. So we see that in both cases they get back to the functional identity of n.